In the 1970s, NASA tried to solve a problem that most people never knew existed. Satellites were failing in orbit, and once they failed, they were usually lost forever. Instead of sending astronauts, NASA made a dangerous decision. They tried to let machines repair satellites on their own. No spacewalks, no human hands, just robots. The hardware was real, the tests were real, and the fear was real. NASA walked away from the idea for decades, not because the robot failed, but because trusting a machine in orbit meant losing control. Today, NASA is quietly returning to the same idea they once abandoned. Why does this matter now? Because modern life depends on satellites more than ever, and even today, fixing them in space is still one of the hardest problems humanity faces. Now we go back to where this story really began. Stage 1, when satellites became too important to lose. By the late 1960s, satellites were no longer experimental machines. They had become invisible infrastructure. Weather forecasts relied on them. Television signals crossed oceans because of them. Military early warning systems depended on them. Scientific research in space depended on them. Civilization was slowly moving into orbit, but satellites were fragile. Many were built quickly, pushed by political pressure, and launched with little margin for failure. When something went wrong, the satellite usually became useless. And most failures were small: a stuck valve, a frozen antenna, a sensor that stopped responding. Tiny problems that killed missions worth hundreds of millions of dollars. NASA engineers understood the danger. Every failure meant lost data, lost capability, and lost credibility. Replacing a satellite took years. Launch schedules were tight, budgets were limited, space was becoming crowded, expensive, and unforgiving. At first, astronauts were seen as the solution. Humans could fix things. Humans could adapt. Humans could save missions. That belief shaped early planning. If something broke, send a crew. Reality was harsher. Astronauts were rare and expensive. Training took years. Launching humans meant risk every time. Spacewalks were slow, exhausting, and extremely dangerous. One torn glove or one wrong movement could end a life. Inside NASA, a quiet realization formed. Humans were not a scalable solution for routine orbital maintenance. They were heroes, not mechanics. Space infrastructure needed maintenance, not bravery. That idea made many people uncomfortable. Stage 2. The idea that made NASA nervous. The robotic servicing idea did not come from dreamers or science fiction writers. It came from engineers, planners, and budget analysts. They looked at the numbers. Robots did not need oxygen. Robots did not need food. Robots did not panic. Robots could work repeatedly without rest. In theory, a single robotic servicer could save multiple satellites. Instead of replacing broken spacecraft, NASA could fix them. The cost savings were massive. The logic was clean. The reality was ugly. Satellites were never designed to be repaired. Most had no handles, no standardized parts, no docking points. Many failed satellites spun uncontrollably, turning them into dangerous targets. Approaching one was risky even for astronauts. Engineers proposed solutions: complex robotic arms with multiple joints, force feedback systems to prevent crushing components, cameras to guide movement, early onboard computers to calculate trajectories and motion, commands from Earth combined with limited autonomy. This was the early 1970s. Computers were slow, memory was tiny, processing power was weak, cameras were blurry. Every movement had to be simplified. Still, NASA pushed forward, not loudly, quietly, carefully, because if it worked, it would change everything. Stage 3, when hardware met reality. By the mid-1970s, the project moved beyond paper studies. Real hardware was built. Robotic arms were assembled in laboratories. Engineers tested joints, motors, and gripping mechanisms. Mock satellites were mounted on rigs to simulate orbital motion. On Earth, the system worked, slowly, deliberately. Every action was cautious. Engineers preferred slowness over disaster. But space does not forgive slowness. In orbit, satellites do not stay still. They rotate. They drift. Some tumble violently after failure. Sunlight blinds cameras. Shadows hide depth. Reflections confuse sensors. Computers struggle to understand what they are seeing. Sensors disagreed with each other. Visual data was unreliable. One miscalculation could send the robot into a solar panel. One collision could destroy a satellite worth hundreds of millions of dollars. Engineers trusted the math. Managers trusted nothing. Inside NASA meetings, confidence began to crack. The robot did not need to fail often. It only needed to fail once. And that single failure would be permanent. Stage 4, fear, responsibility, and politics. The debate inside NASA shifted. This was no longer about engineering. It was about responsibility. If an astronaut made a mistake, there were options. They could stop. They could retreat. They could improvise. Humans could respond to the unexpected. If a robot made a mistake, the mission was over instantly. There was no undo button in orbit. Managers began asking questions no one wanted on record. What happens if the robot destroys a national asset? Who takes responsibility? How do you explain to Congress that a machine caused the loss? Public failure was a nightmare scenario. A robotic failure would not look like an accident. It would look like a choice, a decision to trust a machine over a human. Then came the space shuttle. The shuttle promised everything NASA wanted: human repair missions, satellite retrieval, controlled operations. Astronauts could fix problems directly. Compared to that promise, robotic servicing looked unnecessary and dangerous. Budgets tightened, priorities shifted. NASA did not announce a cancellation. There was no press conference. The program faded quietly. Funding disappeared. Studies ended. Hardware was stored. Engineers were reassigned. The robot did not fail. Trust did. Stage 5, the long silence and the return. For decades, robotic satellite repair vanished from NASA's plans. Satellites continued to fail. Most were abandoned in orbit, turning into expensive debris. The shuttle repaired some, but at enormous cost and risk. Every mission depended on human lives. Then, reality returned. The shuttle was retired. Astronaut access became limited. Satellites became more critical than ever. Banking systems, GPS navigation, climate monitoring, global communication, and national security all depended on machines that could not easily be replaced. Meanwhile, technology changed quietly. Cameras became sharper, computers became faster, sensors became reliable. Autonomous systems improved without headlines. NASA returned to the same idea it once feared: robotic inspection, autonomous docking, machine precision in orbit. The idea never changed. Humanity did. This story is not about a failed robot. It is about timing. Sometimes the future arrives early, and fear stops it. NASA's satellite repair robot was not wrong. It was just ahead of us. Extended aftermath, the cost of waiting. What NASA did not fully realize at the time was how long the consequences would last. By abandoning robotic satellite repair, the agency accepted a future where failure in orbit meant replacement, not recovery. Every broken satellite became a lesson that could not be applied because the hardware was unreachable. Knowledge was lost with the machine. As satellite numbers increased, so did the problem. Orbit slowly filled with dead spacecraft. Each one represented lost money, lost capability, and growing congestion. Engineers began worrying not just about failure, but about collision. A dead satellite could be struck by debris. That collision could create more debris. One failure could multiply into many. This risk was understood decades earlier, yet the tools to address it had been set aside. In hindsight, NASA's decision was logical for its time. The technology was immature, computers were weak, sensors were unreliable, public tolerance for robotic failure was low. But logic does not erase opportunity cost. Every year without orbital servicing hardened bad habits. Satellites were designed to be disposable. Short lifespans became acceptable. Repairability was ignored. That design culture spread. Commercial operators followed the same path: build fast, launch cheap, replace when broken. Space became a place where maintenance was avoided, not planned. The idea that machines in orbit could be fixed slowly disappeared from design rooms. When robotic servicing finally returned decades later, it did not feel new. It felt overdue. Modern engineers rediscovered the same problems their predecessors had warned about: tumbling satellites, non-cooperative targets, harsh lighting, limited fuel. The difference was not the problem, it was the tools. Cameras could now see clearly. Computers could process images instantly. Autonomous systems could adapt in real time. The robot had not changed. The world around it had. There is another cost that is harder to measure: human risk. For years, astronauts were used as the solution because robots were not trusted. Spacewalks became routine, but they were never safe. Each one carried danger that could not be eliminated. Robotic servicing could have reduced that risk earlier. It did not because fear outweighed possibility. NASA's robotic repair program failed quietly, but its shadow is long. It shaped how spacecraft were designed, how missions were planned, and how risk was assigned. It delayed a future where space infrastructure could be treated like infrastructure, not disposable hardware.